This animation shows the construction of the K-Star machine in its time sequence. It has been produced for education of the personnel related to K-Star machine system integration, and eventually for PR of the K-Star project. This building is constructed in the shape of Kobuksan, Korea's traditional armored warship. In this building, the K-Star machine and relevant attachments are installed. It is designed and constructed to have maximum 1.5 meter thick concrete in order to minimize the exposed radiation that will be generated when the K-Star is fully commissioned. Now we are entering the main experimental hall, where K-Star's major components are constructed and assembled. These are embedded plates on the floor of the main experimental hall. They provide the zero-level reference surface for the height of K-Star. On the plates are installed the cryostat supporting beams, which play the role of cornerstones for the whole K-Star. Supplementary jigs and fixtures for assembling main components are required in order to integrate K-Star. As one of them, the main base frame is installed. Now a cryostat is being installed. Now on the screen is installed the gravity support sustaining the load of K-Star's superconducting magnets. After gravity support has been installed, the main jig system for assembling the TF magnet is installed. The K-Star project team has made TF00 coil for cooldown and current charging test of TF coil and a prototype TF structure for supporting the TF magnet. Once the tested TF00 coil is encased to the modified prototype TF structure, the sub-assembly is called a TF00 magnet. To verify the performance of the main jig, the loading mechanism, rotational performance, and installation accuracy of the TF00 magnet is tested and corrected for improvement. After the performance test of the main jig has been completed, the main jig is partly removed and lower PF coils, PF6L and PF7L are temporarily positioned. While the main jig is partly removed and lower PF coils are temporarily positioned, the 180 degree and 157.5 degree sector of the vacuum vessel are delivered to the site and welded to form a 337.5 degree sector in another place of the assembly hall. After the sub-assembly of the 337.5 degree sector vacuum vessel is completed, the external Rogowski coil is installed, and then the thermal shield is installed on the vacuum vessel. Thus assembled, the vacuum vessel and thermal field are lifted by a 150-ton overhead crane and moved to the Tokamac pit. Then the main jig is reassembled for TF magnet installation. Once the vacuum vessel is positioned and the main jig is reassembled, the TF magnet is assembled, which is the highlight of K-Star assembly. the TF magnet is passed through the 22.5 degree gap by two TF transfer vehicles, positioned on the Hillman roller, and rotated to the opposite of the input position. While the TF magnet is rotating, the supporting beam and horizontal stabilizer sustaining the vacuum vessel repeats being disassembled in turn, and then reassembled again after the passage of the TF magnet. The 2nd to the 15th TF magnets are rotated to the position in a toroidal direction, just like the process of the first magnet. The rotational direction progresses in zigzags. Between two neighboring magnets, various shear keys or conical bolts are manufactured by on-site fitting and then installed. The last TF magnet assembly is the most difficult process in the K-Star assembly. Therefore, the 22.5 degree gap for assembling the last TF magnet is accurately measured by an optical meteorology system, such as a laser tracker. In this way, the thickness of the insulation plate for the attachment of the last TF magnet is determined. Then it is assembled by a very accurate straight line movement. This process can be repeated several times to make the accuracy meet the assembly tolerance. Once the last TF magnet is thus positioned, insertion of various shear keys, preloading, final positioning, and magnet axis datum setup continue. Once TF assembly is completed, the vacuum vessel thermal shield of the last sector is installed. 24 small parts for vacuum vessel temporarily stored in the vacuum container are installed in their position by a robot, and a vacuum seal is established by welding. Once the vacuum vessel assembly is completed, the leaf spring type vacuum container supporter and 12 bottom vertical ports are lifted from the Tokamac pit and assembled by welding. Then the vacuum vessel is finally settled down.